What's on the test? Okay. The written section has 3 or 4 questions. Plus 1 using principles of physics, right to explain question. Okay? So the written has 3 or 4 and a using principles of physics, right to explain. What are you going to see on the written section? I guarantee you're going to see something like a collision at angles. Collision at an angle. Like question, let me go find one. I wrote down here question 14. Was that a good collision at an angle? Yeah, let's do one. You know what? Let's shake things up a bit. What was 18? No, come back to that. 28 I wrote here, Mr. Dueck. What was 28? Nah, come back to that. 19 I wrote here. What was 19? Nah, come back to that. 30 I wrote here, Mr. Dueck. 30. 34. Know which one? Ah, here we go. Sure. So something like this, except I'm just going to change the numbers. Okay? And the reason I picked this one is just for a change before the collision, what's moving? Both not stuck together. After the collision, stuck together. I was just looking for a dip because our questions have been always similar, so I wanted to find a mix and match a little bit different. Can I do this so I can see you?
Did you
So,
ever do this one where they're both moving before and after?
in a nice straight line, yes.
Like they were like.
In a nice straight line, linearly, sure.
Okay.
Sure. At angles,
Not angles though?
I don't think so. Bear with me, someone's trying to get into this. So just to try and find a slightly different collision question, so like number 34, for example. Okay, but I'm going to change the numbers a little bit. Hopefully, when I make up the numbers, so like question 34 from review, hopefully if I change the numbers, I hope this will still work. So I'm going to say instead of V1 being 1.8, I'm going to have it be 1.6 meters per second. And let's make this 3.8 meters per second. And they stick together and they move off at, let's have them go faster, 2.5 meters per second. Hopefully this is not physically impossible. By the way it would be impossible is if my final kinetic energy was more than my initial kinetic energy, but I think I'm good. Okay? Cool, what are they asking us to find? Velocity. Really, right? Magnitude and direction. There's a collision. This is a job for conservation of momentum. So I would probably start out by saying the sum of all the momentum before equals the sum of all the momentum afterwards. Oh, I can't do that. Dope. That was dumb. Okay, I'm stuck with this diagram. Then I would say before the collision, what's moving? Mass 1, mass 2, or both? So stuck together or separate? So I would probably say, okay, momentum of mass 1 initial, momentum of mass 2 initial. Anyone? Anyone? Bam! They collide. Okay, I thought someone would fill it in. Afterwards, stuck together or separate? So it's going to be momentum of both. Final. Now what that means is you've noticed to find the velocity we're dividing by the mass. Well, in this case, I guess to find the final velocity, we'll end up dividing by the mass of both of them. Okay? Now, are there angles? See, if it was a nice straight line, then I would go M1, V1, M2, V2, and I would make sure anything to the right was positive, anything to the left was negative. I would look carefully if there was a change in direction. Definitely one's negative, one's positive, and I'll talk about that later. But angles, I dulp. I draw a little picture. So I like, let's see, here's incoming momentum 1, and I can even tell you how big it is. First of all, it's coming in at a little 30-degree angle right there, and it's 3.8 times 1.6. It's mass times velocity. 6.08 plus, I don't know this, but that is, I can tell you as a picture, something like that, based on the picture that they gave me. That makes it a lot easier. So I'll call that momentum 2 initial. And apparently after they collide, it goes a nice straight line, and it's going to be mass, which is both 3.8 plus 1.3 times velocity. Clear. Bracket 3.8 plus 1.3 times 2.5. So it looks like the momentum afterwards is 12.75. How on earth can I add these together? Draw them tip to tail, and the nice thing is I know what the resultant is supposed to look like. And what I said to you, Joel, you're going to have two situations. Either you'll know both of these and you'll be finding the resultant, or you'll know what the resultant looks like, and almost always it'll be a nice horizontal or vertical line, which tells you how far to draw the second one. In other words, Joel, my vector triangle is going to look like this. 6.08, and then I'm going to go up. Tell me when to stop, Joel. Here? Why is that probably too far? Yeah, I overshot. Yeah. Go, 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 go. Stop. Okay? And I'll try and be roughly to scale. 12 is roughly twice as big as 6, so I'm eyeballing it, but hopefully my resultant is about twice as long, maybe. I need an angle. Oh, by the way, here's what I'm trying to find. I need an angle. Well, it definitely said that was 30 degrees. How's that help me? See the Z trick. That there is also 30 degrees. Sohcahtoa? Cosine law. By the way, so having marked block C's, one of the most common mistakes I saw, forgetting the square root. I saw this. The problem was the answer you got wasn't very big, because it just so happened the masses I used on the test aren't that big, so it doesn't stand out. Oh, I've got a momentum of 3,400,000, where it's obvious you need to square root, and that was partly on purpose. I know it was sneaky of me, but I was got to remember the square root. Plus, no, minus, Mr. Dueck, minus, Mr. Dueck, minus, Mr. Dueck. 2 times 12.75 times 6.08 cos 30. Whoop, cos, it's the cos law, Mr. Dueck. 30. So I saw a lot of people say, oh, the momentum is 65.26. No. Forgotten the square root. 8.0784. Of course, that ain't what I wanted to find. I wanted to find the velocity of object 2 initial. That's going to be that 8.0784. Is that right? 8.0784. for sure, divided by the mass of object 2, which was 1.3, right? Uh, 6.2, 6.21 if you want meters per second. I need an at. Okay. I guess what I want to find is that angle. Bree, look up. I certainly don't want this angle because that's a slanty next to a slanty. That's not a north of south or east. That's a nothing. So I definitely don't want that. So if I don't want that, extend a horizontal or a vertical line as necessary. That's what I want, which if I do my Z trick, I think really means I want that. Oh, except the angle that I want, which is the bottom one, this guy here, is what of what? North of south, east of west, what of what? And I really should have drawn a compass rose up here earlier, but okay. Oh, sine law. Let's do that right here, I hope. The sine law says the sine of the angle that I know, 30, divided by what's across from it, which I didn't used to know, but now I know is 8.0784. So common mistake number 2 that I saw, kids didn't put the momentum here. You know what they put here instead? Velocity. Why? Because subliminally it was staring at them on their calculator. Don't do that! Equals sine theta
Your bus is leaving.
over
Your bus is leaving.
6.08. Third most common mistake I saw, kids couldn't cross multiply. That's math 8. It's going to be 6.08 sine 30 all over 8.0784. 6.08 sine 30 all over 8.0784. And what the? Oh, I haven't found theta. What have I found? I did see a few kids write that as the angle. Yeah. 22.1 degrees. Pardon me? 2 of them. Or they had their calculator in radians. I don't remember. Okay. So I like that question. I like that question. I like that question. Where I'm giving you 2 vectors at an angle, find the third momentum, find the third velocity. Okay. Other questions like that. So the one that we did was 2 objects coming in, sticking together, or the other ones you did a bunch of where one object was coming in and the other one was standing still and they glance off each other. So regardless, you still start out with before the collision, what's moving, mass 1, mass 2 are both stuck together or separate. After the collision, what's moving, mass 1, mass 2 are both stuck together or separate. Okay. Oh, don't want that. Then what are you going to see on the written? Boom! Explosion.
2 more minutes, Miss Sarich. 2 more minutes.
Explosion. Looking at your review, I'm noticing there weren't that many explosions. I'm actually going to say, like, scholarship number 47. And I'm going to have to make up some explosion questions and throw them on here. There was lots of explosions where there was only 2 masses, and it was linear. So, for example, there's the 2 kids pushing against each other on ice skates. That's arguably, Joel, an explosion, because before your momentum was 0, so after your momentum is 0. But, hey, this is an explosion, too. Slow one, but, yep.
What about the, like the flying disc shatters ones?
So that one was also technically an explosion. That's a bit more difficult though because it's moving. Your initial momentum wasn't 0.
Yeah. But
So-
is that like a good question of like a good example or?
That's a more advanced example of an explosion that I'm going to give you. So if you handle it, you're probably in
Okay.
good shape. I don't think that one exploded into three masses, did it?
I can't remember.
That I can't remember either. I know this one does. So I'm going to go like this. Okay. Except, let's say 45 and 75. There, now it's a whole new question. I'll even leave the rest of the masses the same. Oh, 55 kilogram is the 45 kilogram and the 75. So it says this: a stationary life mass, 160 kilograms, is carrying 2 survivors with masses 45 and 75 kilograms respectively, in that order. They dive off the raft at the same instant. The 45 kilogram person due east. Ha! And the 75 kilogram person due north. In what speed and what direction does the raft start to move? I'm kind of visualizing this. I think if you dive east and someone else dives north, I'm pretty sure the raft is going to be moving southwest. Like it's going to be west of south or south of west. I don't know how many degrees, but I can tell you, there's my error check. Is this a collision? No. Is this an explosion? Technically, slow explosion. Regardless, it's still a job for conservation of momentum. What differentiates an explosion from a collision? What makes this different from a collision? Well, because
Back to the start, right?
well, because your initial momentum is what?
0.
So your final momentum is what?
0.
So my definition for an explosion is, you know what? The momentum's 0, which means everything must cancel out. So if you're in a nice straight line, that's nice. One's positive, one's negative. Or if it's a vector triangle, what did you say?
They come back to the start.
End up back where you started from. So before the collision, what was moving? Before the explosion, what was moving? Nothing. After, now that is true, by the way, the final momentum is 0, but I want to break that down into its vector component parts. So I'm going to say, boom, it explodes. Momentum 1, momentum 2, and you know what? I'll even go momentum R for Raft, since that's what they're talking about, and that's, more likely that I won't find the wrong momentum or mass accidentally. Looks like the 45 kilogram person dives due east, that way, and it's 45 times 4.4. Nope, 45. It was 45, I said, yeah, times 4.4. Type that in, 198. So 45 times 4.4, 198 kilogram meters per second east, combined with the other person dives north, and that's 75 kilograms times 4.2. Wow, 315 plus, don't know. Any suggestions? Sure, I got 2 vectors. So this is roughly 200 by 300. So 200 will be about 2/3 as long as 300. It'll look kind of like this. Well, yeah, try that again. 200. 198. How would I actually put the numbers on there? That was dumb. And 315, I was doing my rough guess. And what makes this an explosion is, what do I want to do now?
Come back to the
Yeah. So I did see on the that's terrible. I did see on the explosion question a number of people drew it that way. Don't do that. That would be if you were adding those two together and finding a resultant. I'm not. This is the momentum of the raft. On your quiz, I gave you one like this where it was the sine law, cosine law. It was pretty nasty. On the test, it'll be a nice Sohcahtoa question. In fact, I would argue, I think I can find the momentum with Pythagoras. If I go 198 squared plus 315 squared equals square root, I get 307, don't forget square root, I get 372.06. Looks like the momentum of the raft is 372.06. So the velocity of the raft is going to be 372.06 divided by, what was the mass of the raft? 160. Divided by 160. And I get 2.33. 2.33 meters per second at, look at the red line that I've drawn. Am I going to use the bottom left or the top right corner of this triangle? Where am I going to put theta? Yeah, always where it's coming from. That's why it's so important to get the original diagram correct. So if you do that,
You do the arrow backwards and you
yeah, and that happened an awful lot. I saw lots and lots of those. Yeah, you'd be getting a
What if you found,
north of east instead of a south of west or west of south or something.
I feel like this mistake I might make is like put the theta on the outside of that one, like on the top left.
I accept it. Just hang on.
Oh, okay.
So right now I can use straight Sohcahtoa. Yes? Right? Which would be which trig function? Turns out tan theta is 198 over 315. Don't need to pull out the sine law here. Although the sine law would work, by the way. Just not necessary. And I get 32 degrees. 32 degrees. What of what?
South of west or west? I don't know.
Which one? South of west or west of south?
I'm gonna say west of south.
Convince me.
Because the arrow's coming from the south line.
Oh yeah, I had to go to the west from of south. Now, Callum, going back to your question, had you put the theta like that, which is that theta there, okay, you would have ended up with 58 degrees south of west, as long as you use this as your what of what. And I'd take that too. For all of these, I always take two angle answers. The angle and the what of what, and 90 minus the angle, called the complement, and the opposite and opposite. So if it was north of east, the second angle will be east of north.
Okay, sounds good.
Is that all right? So give me explosion. I think on the test, actually, once you got this far, I asked you to do something with this answer. I won't be more specific than that, but I said, nah, do something with it. Okay. Third question is a roller coaster collision kind of a question. Like, I think 19. Wow, I got the yawns. I gotta wake up. Sure, but I had a better one than that. 28, apparently. Oh. 30. Here you go. So, third question. Combined energy and momentum question. like the ballistic. Ryan, can you read that to me? So I wrote 3 combined what?
Combine energy and momentum, like the ballistic pendulum or the colliding roller coasters.
No, not what I wrote. Listen closely. I wrote this. Combined energy and momentum like the ballistic pendulum or the colliding roller coasters. I wrote combined energy and momentum like the ballistic pendulum or the colliding roller coasters. That's what I wrote. I'm surprised you didn't see that.
My mistake.
Obviously your mistake. Okay. Well, I thought about doing the pendulum. I'm in the amusement park right now. So, okay. Are you guys okay on the colliding roller coasters, and then how high will they go? So there's an energy component, collision momentum component, okay? And in fact, I think what I did is I started at the top of the hill, find how fast at the bottom, energy. Wham, they collide, momentum. How high do they go together? Energy. Yep.
Is there going to be a question like one that's like, I don't know if you remember the one I asked earlier, like it drops, you have to find
Yeah,
the...
I know. I remember the one you asked me earlier. Hang on.
Oh, yeah.
Like question number 30, for example. Okay? So you guys have said you're okay on those, and it'll be a linear collision. Okay? So I'm not going to give you a combined energy on the written and then have a nonlinear collision. I would feel as a nasty okay in giving you something like this on the multiple choice. Look up for a second. I would have no problem saying, instead of determine the speed and direction, I would have no problem saying, find the initial kinetic energy of mass 2. Kinetic energy is what? Half mv squared. You know what? You'd still have to walk through all of this, except you wouldn't have to bother finding theta. Once you had v, you would then go a half mv, because it's a scalar squared. That would be a nice twist. And I would have no problem doing that on the multiple choice, say, as kind of a twinge. Or, instead of just saying find the initial, I could say find the change in. What's change in anything when it comes to... So, if I said find the change in kinetic energy, the final kinetic energy would be a half both masses, 2.5 squared. The initial would be a half 3.8 times 1.6 squared plus a half 1.3 times 6.2 squared, and go final minus initial. That would be fair game.
Yeah.
I don't think I'm going to throw one like that on the written. But there were, in fact, I think number 2 or number 3 was like that. Going from memory here. Oh, sure, number 2. How much kinetic energy is lost? Oh, that's really saying what's the change in kinetic energy, except change in is technically final minus initial. Here it's saying how much is lost. So I think you'll actually end up going initial minus final if you want a positive answer to say how much was lost, because you've lost some. Okay? So you folks say you're okay with that? Good. $21 is a question that I thought was meant to be, actually not 20, well, not 21, 28, I think. Let me look.
Really?
Hang on.
21's like multiple choice.
I know. It's okay. Sure. 28. Let's change that. Something like 28. And what I mean by that is, okay. I can make this a written or a multiple choice, but I'm just going to copy the question and not bother copying the answers. What I mean is this. Where there's a change in direction. So, you know what? 16, 28. What's this question asking me to find?
Magnitude, direction, slope, velocity.
Of what? I heard the magic word, what? Impulse. Well, impulse is, did they mention a force or a time? Nope, don't use that one. Impulse is also, which means final minus initial. Okay? But here's the key to this. Is it rebounding? Is there a change in direction? Is it rebounding? Is there a change in direction? Well, or you could flip them. I don't care. But I'm telling you. So it's going to be like this then. So right now I'm letting west be positive and east be negative in my question. Why? I learned a long time ago I tend to let my initial be negative because then I get a minus minus, which is a plus, and I make less dumb mistakes, just me being me. So this would be 0.08 final minus 0.08 initial, which is what? Can't be negative.
I did the other way around. Final was negative 5.2.
3.52? I might have been wrong. I wasn't paying attention. Minus.
Oh, it's 0.08, yeah.
Yeah, okay. Kilogram meters per second or Newton seconds. Now here's the key. It said, what's the magnitude? 3.52. What's the direction, east or west? And how do you know? Why west? What direction did I let be positive? What direction did I let be positive? West. What kind of an answer did I get? Positive or negative? And if you had let east be positive and west be negative, you would have got a negative answer, and you would have, okay, it still matches my negative direction, and you still would have said west. So this question here, something like that, right? This is one that drove me crazy. I had a similar question, and kids missed the change in direction. A whole bunch of kids. And I stressed that, I think, during the unit. I said, be careful. Let to the right be positive, let to the left be negative. Hopefully I've used that phrase a few times. Okay? That seems to be what I thought was fairly easy linear. A lot of kids are getting that one wrong. Disappointingly to me. Because they're all going to kick themselves. And unfortunately, because they got that wrong, they got the magnitude and the direction wrong. So it cost them twice. Oof. Okay. Are there any questions from the review that you would like me to go over? Otherwise, I'm going to finish with, here are the questions that I've talked about the written.
Could you talk about some of the principles of physics questions?
I rarely do because I drop those hints during class. Okay? And I've dropped that, believe it or not, I have dropped a hint sometime during this tutorial, and I've dropped the hints during the actual lessons as well. But the using principles of physics, those ones I tend to, if you ever see me go on a little rant about something in a demo, your ears should perk up. Or if I put my pencil down and I stand in the middle of the room and I start talking about something really enthusiastically, your ears should perk up. There's usually about 4 or 5 mental using principles of physics questions I have in my mind per unit, and if I go on a rant, that's probably my way of saying, hey, one of these might be fair game. But I don't give more specific than that. Sorry, kiddo. Good question, but sorry. But I actually, believe it or not, I've dropped a hint during this a fair bit without you realizing it. If I've done my job well. And, well, in other words, if you're good on everything we've done, then you should get it. Okay? Any other questions from the big review?
I don't really have a specific number for it, but like I feel like it should be easy, but finding work done during a collision or like work energy done during a collision.
See if I can find one. Oh, by the way, when it wants the work done, it's really saying find the change in kinetic energy. Okay? So let me see if I can find one. Oh, sure, here, number 10. I don't know if that's quite what you had in mind, but I just noticed it said how much work is done. I also noticed a change in direction, so this might be a good time to, practice a couple of things. And you know what, Joel, just in keeping with this way you can still practice your own homework, let's make the girl 50 kilograms, and let's make the boy, let's leave him at 45. Okay? He pushes her, so how much, what's this question asking? How much total work is done? Well, work is going to be, it is force times distance. Do you see a force or a distance anywhere here? No. It's also the area under a force versus distance graph. Seest thou a graph here? No. Our third definition was, and the fact that they've given me a speed suggests maybe this is, and masses, maybe this is the way I want to go. Okay? What's changing anything? What did I just underline? That's nice. What's the final kinetic energy? Well, I think the final kinetic energy is going to be the kinetic energy of the girl combined with the kinetic energy of the boy, which is going to be a half m girl v girl squared plus a half m boy v boy squared. So far, so good? Well, let's see how much of this I know. Do I know the mass of the girl? Sorry, let's do that. Fix that one too. Do I know the mass of the girl? Do I know the velocity of the speed of the girl? Do I know the mass of the boy? This is easy. Do I know the speed of the boy? So even though it's saying find the total work, you know what I'm going to spend most of my time doing? Okay. How? This is an explosion. It's a slow explosion, but it's an explosion. Right? Right? And before the explosion, what's the momentum? Yes. After, it must be that, but I don't want to write 0 equals 0. Now, do you see angles, or is everything in a nice straight line? So I can just say momentum girl and momentum boy. Yes? And you said everything's in a nice straight line, and I agree, so I can really just go this. Mass girl v girl plus mass boy v boy, although the velocities should be vectors. What are we trying to find? That's the one that's the one we're missing. Velocity of the boy. I think I would find that by, I think I would get this. Negative mass of the girl, velocity of the girl, divided by mass of the boy. I think that equals v boy. Is that right? Did I do too much? I minus that over and then divide by mv. Yes? Yeah. Now it's plug and chug. The velocity of the boy is going to be negative, opposite direction of mass of the girl. 50. I scroll down. 2.4 divided by mass of the boy, 45. And although I'll get a negative answer, because it's a vector, it's saying in the opposite direction of the girl, when I go to energy, it's a scalar. The negative is going to cancel, so who cares? And it's going to be a half, so it'll be then be a half mv squared plus a half mv squared. That'll be how much work. And it won't be any of those answers because I changed the numbers. But there. They say how much work? Change in kinetic energy. If it's a collision, even if it's at angles, once you've found the final speeds, the nice thing is energy is a scalar. It's still going to be a half mv squared and a half mv squared. You don't have to worry about the what of what, how many degrees what of what. Who cares? So in some ways, the work thing is easier once you get there. Is that okay?
Yeah.
Yep. I think there was one also where it asked how much work at angles, or what was the, let's see. Find the mass. Doo-doo. I swear there was, Mr. Dueck. Again, by the way, hint, hint, 31, rebounding. Don't you dare use 11 and 1.3. You better make one of those negative. And I would probably make the 1.3 positive, even though it's pointing to the left. And I would make the initial negative, because then I get a lovely minus minus, which is a plus. But whatever. Joel, I'm sure there was one where I gave you at an angle, but instead I said how much work or change in kinetic energy. Maybe not. Average net force. Speed. Okay. But that would be fair game to me.
Is there any sort of help you can go to for multiple choice? That's where I lose my answers.
I already have.
Okay.
Now, other questions that I like, so I told you all about the written. Here's what I told my other class. I like question. This is what well, hey, Mr. Dueck, why don't you be clever?
Yeah, it's like I'm telling I'm not stubborn, clever with multiple choice.
But you know what? I kind of, for you as a high-achieving student, find that process healthy. Here's what I wrote. I like number 1, 14, 16, 18, 19, 21, 22, 24, 26, 28, 30, 31, 34, 39, 45, and 47. If you did nothing but look at those, you've seen at least 85% of the test. But do more than that because it's good practice. Okay? Any other questions? Any other weird ones? Any specifics you'd like me to go over? There's really not that much to this test. I broke this big unit into 2 smaller ones, which I'm glad I did.
Bring up any other units, like kinematics and stuff?
I would have, I think it's totally fair game to ask you to find a distance or a velocity or an acceleration or something. So as a multiple choice, nasty momentum after a collision, rather than say find V final, I could say after 10 seconds, how far has it traveled from the collision?
Okay.
Come on. Oh, I gotta find V. No acceleration. He said frictionless. I'd have to phrase it carefully or something like that. That would be fair game. Even if the collision lasts however many seconds, what's the acceleration? Especially if it's a nice linear collision, you have V final, you have V initial, you know, A equals VF minus VI over T. That would be fair game. So in answer to your question, yeah, everything from previous units is fair game. That's one of the things, though, I like about Physics 12 is you may have noticed we have been fairly frequently bringing out force or mass or VF or D. We're still flogging stuff actually from Physics 11 fairly frequently. I wish more courses were set up that way. We review along the ways.
Tests could get really hectic in like the 9th unit. Like, oh,
No, the test could be mostly review on the 9th unit. Your glass is half empty, my friend. Mine's half full. The test could be, oh boy, I've been doing this for 2 years, piece of cake. I've been doing that for 2 years, piece of cake. Ha, I've been doing that for 18 months, piece of cake. Oh, that's from November. I aced that already, piece of cake. Oh, yeah, here's the only new thing.
Oh, yeah, I guess so.
Got to think of it the right way, my friend. Now, if you were someone who had bombed on test after test after test, then you got to be nervous, but you're not in that case.
Thanks.
Okay? So, Got to think of it the right way. My block C's, the class average was pretty high. Class average was 82. But what's ticking me off still, they're going to kick themselves on dumb mistakes. And so I've tried to drop some hints about some of the dumb mistakes. The square rooting. The other one that happens, kinetic energy, forgetting to put a squared, right? We've seen that one before as well. Don't do that. Those are the two really irritating ones. Sloppy vector diagrams. It's always interesting. The kids that are the weakest try and take the most shortcuts. You know, I can't do these in my head, and I always see some kids that they'll try and do it in their head. Hey, let me brag for it. If I can't do it in my head, you guys aren't doing it in your head. It's pretty clear here. So, be a good test writer. Thursday, first of all, I'm around tomorrow after school if you have any last minute questions, but I'm going to give priority to my other students who I've told not to come today. I'll be in Thursday morning-ish. I usually get here around 7:45 or 8, somewhere in there. Depends on traffic, depends on caffeine and how tired I am. Depends on whether I have a newspaper when I'm having breakfast or not. Who would like a copy? Hang on, first of all, let me save this.